Okay, so now if we take a look at the next issue, okay, we kind of reviewed how to deal with greatest common factors, how to undistribute or factor out the greatest common factor. Now, difference of squares pattern. You might remember this. So the difference of squares pattern is just this. If I have something squared minus something squared, so A just represents one thing and B represents the other thing, right? This is what we call a difference of squares. Difference means I'm subtracting the two, right? So I've got one square minus another square. That always factors using this pattern, right? It's the first thing minus the second thing times the first thing plus the second thing. Okay, so let's look at a quick example. Like what if we wanted to factor b squared minus 49? So our goal is, can we get that to look like the blue pattern? Can we get that to look like something squared minus something squared? Well, yeah, the first thing is just a b, isn't it, right? That's just b squared minus 49 is what squared? 7 squared. Good, that's a perfect square. So if we follow our pattern, what's our pattern tell us? Well, we get the first thing minus the second thing times the first thing plus the second thing. Okay, that's the difference of squares pattern. It's a really easy way to break things apart when it fits that pattern. Okay, now another thing to remember about this, though, is that sometimes we want to overgeneralize in math. There is no sum of squares pattern. It never works. So if we have something in the form something squared plus something squared, we're done. It does not factor. There's no pattern that goes with that. We can't break it up any further. Okay? All right, let's try this. How about this one? Okay, can we make that into something squared minus something squared? And if we can, it's going to fit this pattern, right? Whoops. If we can, it's going to fit the pattern a squared minus b squared. And what was that pattern again? See if you can do it from memory. A squared minus b squared is what? Times a plus b. And you can switch the order around. It doesn't matter, right? Doesn't matter which one you put first. Okay, so what's my a this time? Well, we just did that one, all right? 49 is what it was 7 squared. Okay, but what about that one? 16x squared is what times itself? 4x, right? Because I've got to get the number 16 out of it, and I've got to get an x squared. So I'm going to square both parts of that. Does that make sense? Because we know, whoops, I don't want to do it there. Because we know that 4x squared equals 4x times 4x. And what do we get from that? Well, when I multiply things together like this, we can do it in our head, but we're really probably commuting things in our head and multiplying things in a convenient order, aren't we? We're really probably thinking of this as 4 times 4 times x, right? So we get 16x squared, okay? So then what's my answer going to be? So this is my A, and 4x is my B. So what am I going to get out of that then? What's it? Good, so whatever my A is, 7 minus my second thing is a 4x times whatever my first thing is. My A is a 7 plus my second thing, my B is a 4x, and that's it. There's my answer. Okay, good. All right. How about that one? Say it again. No, an 8 isn't either, right? But what do we always want to try to do first? I'm going to go back a little bit here. Always factor out the greatest common factor first, if possible, every time. We can't forget to do that. I know we're focused on something different now. We're focused on the difference of squares pattern. But our first step is always when we're factoring to see if we can undistribute something. So is there something we can undistribute there? What's the biggest number that divides into 128 and 8? In fact, I think 8, doesn't 8 go into, oh no, it doesn't, you're right. Oh, it does. It does. 8 goes into 128, right? 8 goes into, right, 16? Everybody agree? 8 goes into 12 one time with 4 left over, and 8 goes into 48 6 times, right? So 16. Okay, so I could, in this case, look at this. I could undistribute the greatest common factor. I can take out an 8. And do they have any common variables? Y. Good. I could undistribute an 8y, couldn't I? And then I'm left behind. If I do that, I'm left behind with what? 8y times what is 128 x squared y? 16x squared. Everybody agree? Another way of doing that would be to say 128 x squared y divided by 8y. Well, look what happens here. We could cancel the y's, and 128 over 8 reduces to 16 over 1, right? And so I end up with my 16x squared. Well, 8y times what is 8y? So I'm subtracting 1 there too, right? Okay, now that gets us started. That kind of shakes things up enough that now maybe I could go a little bit further. I factored out the greatest common factor. Let me rewrite this. So we got 8y times 16x squared minus 1. So are we able to now write this part in here? And I'm going to put this in brackets because I want to have some other parentheses there too. Anytime you have grouping symbols within grouping symbols, I personally like to make the outside one a bracket so it's easier to tell them apart. So my question now is, can I write this thing as something squared minus that thing as something squared? Can I write this as a difference of squares? Well, 1 is equal to what squared? 1. Okay, so B is 1. What about A? 4x. Okay, right? Everybody good with that? And so now we know what our pattern is. We know that our pattern what happens if I have A squared minus B squared? That's going to work out to be what? So I have the quantity 4x squared, that's my first thing that's being squared, minus 1 squared. Using my pattern, my difference of squares pattern, what am I going to get? 4x minus 1 times. Done. Everybody agree? Okay, good. You guys are doing great, man. Questions, online crew? Does that make sense? Okay. Okay, how about this one? Can I write that as something squared minus something squared? Well, the first one is already something squared. What's the something that's being squared in the first term? Y minus 7. It's already done. And the something that's being squared there is obviously an 8, right? So what's this one going to factor into then?
It's going to be 8 minus.
So let's follow our pattern here, right? We've got our pattern of A squared minus B squared equals A minus B, right? Times A plus B. Okay, well, A is Y minus 7, agreed? Okay, So I'm going to have a y minus 7. I'm going to need some brackets here, right? Because I've got parentheses already inside my grouping. So y minus 7 minus what? 8. Everybody see that? So there's my a minus b times a plus, oh darn it, don't want to do that. Probably going to run out of room here. I gotta be a little more careful with my spacing, don't I? Let's see here. So oh, I didn't write the minus b. You're right. Minus b plus b, right? That better? Now I fit it in. Everybody get that? Okay, good. But we can simplify these a little bit, right? Look at this. We get y minus 7. Do I need those parentheses there? Can I erase those parentheses around the y minus 7? What do you think? I have them there because my a was that quantity. But the only time I need parentheses is if something is being done to that quantity. Something's being distributed or it's taken to a power or something like that. Is anything being done to that y minus 7? No, nothing's being done out front. There's nothing being distributed. There's no exponent, right? So I can get rid of those parentheses. I don't really need them. So I end up with y minus 7 minus 8. Same thing here, times y minus 7 plus 8. Well, what is y minus 7 minus 8? Y minus 15. And I'll turn those back into parentheses now because I don't have any, I don't have two layers. So I get y minus 15 times y minus 7 plus 8. Isn't that y plus 1? We got it. How about that? Those are pretty challenging, I think. Okay, good. See if there's anything. I think that's it for those. Oh yeah, one more. Do we have time for one more? Oh, darn it, anyway. Okay, we'll finish up that last one next time, and then we're moving on to the next factoring trinomials. All right. Have a great day.